All right, so the method itself is not too bad, right? We recognize that if we have a curve that can be set up in this way, we're going to be able to find its volume of rotation by knowing something about our radius, right? If you remember, we can say our volume of a shell, right? Just if you keep this in mind, the volume of a shell is always equal to 2 pi r, which is the circumference, times the height, which is our f of x or f of y, right, times dx, right, for each shell. And the trick right here for our total volume by formula is going to be something like 2 pi times an integral from a to b, our limits of integration, of some radius times f of x dx. The trick sometimes is trying to figure out what is our radius actually going to look like. Let's consider this example. We've got the curve y equals x squared bounded by the lines y equals 0 and x equals 1 and rotated about the line x equals 2. Well, here's our curve, right? Here's y equals x squared bounded on the interval from 0 to 1, right? 0 and the line x equals 1. So what we're going to do is we're going to rotate this about this line at x equals 2. And we want to figure out what would be the volume that we're going to get by doing that. Huh. All right. Well, we need to know what our radius is. So let's check this out right here. Let's see. Our radius is going to be found by going to the disk, or our dx strip, to the line x equals 2. So our radius is no longer just going to be x, right? Is it? It's going to be 2 minus x in this case, right? Whatever value of x we have from here to here has got to be taken away from 2 now to give us our radius. Our function height, luckily, is still the same, right? The function's height is always x squared. So really, our volume in this case is going to be found by taking 2 pi, our integral, using our limits along the x-axis here of that yellow portion, so that's 0 to 1, of our radius, and in this case that's 2 minus x, times our function x squared dx. So when we evaluate this guy, we're going to get 2 pi times an integral from 0 to 1 of 2x squared minus x to the third dx. Oh, and working this out, let's see, 2 pi is going to be multiplied by the integral, so we're going to have 2 thirds x to the third minus 1/4 of x to the fourth, evaluated from 0 to 1. We know that at 0, the whole expression is going to be 0, so we're really left evaluating 2 pi times the quantity 2 thirds times 1 minus 1/4 times 1. All right, let's see, what do we got right here? 3 and 4 share 12 as the common denominator. So we're going to get a 2 pi times over 12, let's see, 2 times 4, 8, minus 3, 5/12. So we're going to reduce this down. We're going to get 5 pi over 6 as this volume right here. So the real trick right here is knowing where do we get that radius. So you have to look at your axis of rotation. If it were simply just x equals 0 or y equals 0 as an x or y axis, we would simply just say x or y. But in this case, be careful. Where is that center at? Okay, good luck with your homework.